Okay, this video is designed to help you get through the classwork we did on Friday and get through the homework that I gave out over the weekend. The lesson is the three properties of algebra and simplifying expressions, and then when we get to the homework, we're simplifying polynomial expressions. We'll talk more about that in detail in this coming week. Here for number 23 on the classwork, start by distributing this negative. You can pretend there's a 1 right there. You've got a -1 that you're distributing across the subtraction inside the parentheses. So since we've done nothing to the -2n, we'll just bring that straight down. But now -1 times +9 is -9, and -1 times -10n is +10n. And now that we've done the distribution, we can go about the business of combining like terms. You've got a -2n right here, a +10n right here. If you have a +10 and a -2 and you put them together, you'll end up with a +8n. And we didn't do anything with the -9, so we'll bring that straight down. And that's the answer for number 23. The next problem from the classwork I want to look at is number 29. So before we can combine like terms, we'll start by distributing this -3 to the 10b and the 10. And then over here, we'll distribute the 5 to the b and the 2. So usually a good idea to take care of your distributions first. So -3 times 10 is -30. So the result of this distribution will be -30b minus 30. Be sure to change your sign when you multiply by the negative. And then here, since we're distributing a +5, this positive sign is going to stay the same. We'll have 5b plus 10. And then the last step is to go about combining like terms. So I've got my b's right here, -30b and +5b. Put those together, and I'm going to end up with -25b. And then right here I have my terms that don't have b's on them. They're just ordinary constants. -30 and +10 come together to make -20. So there is a simplified version of number 29. So now I'm looking at the page titled Simplifying Polynomials, and I'm looking at the side where the holes are on the right hand side because this side is actually much easier. It's a better place to start. So I've got here an x multiplying the quantity 12 times x plus 11. So I'm going to use my distributive law and distribute the x to the 12x and the 11. So I'm going to write that out longhand. 12 times x plus 11 times x. And this x times x here, if it helps, think about if you had 6 times 6, you know that's 36, but it's also 6 squared. So x times x isn't any different. We'll just call x times x x squared and change the 12xx to 12x squared plus 11x. Now, the name of the game is combining like terms when we're simplifying. This x squared and this x, those are not like terms. You cannot combine those together. That's like trying to say 6 squared plus 6 is 12 squared. It's clearly not correct. 6 squared is 36 plus 6, that'd be 42 equals 144. So you cannot combine polynomials of different degrees. This is as simple as it's going to get. Looking at the same side of the page, but now in the bottom left corner, there's this gnarlier looking problem, and let's handle this one together. So let's start here. Just notice there are these parentheses right here on the first expression, but there's nothing out here multiplying. I mean, you could think if you want, there's an imaginary +1 that you distribute, but that's not really going to change the value at all. So for this first set of parentheses, since there's nothing multiplying on the outside, there's no negative sign, there's no number, there's no variable to distribute, you can just drop the parentheses and write 14x squared plus 13x plus 12. Now here we've got to be careful because we do have this minus sign right here. So this -1 is what we want to distribute through. You can think of distributing the negative sign, or go ahead and put a number 1 in there and distribute a -1. This is important because if you don't make this distribution, you're going to end up simplifying incorrectly. But it's just the same as the earlier problems. Anytime we have a negative out in front of the parentheses, we got to distribute it. And all it's going to do is change the signs of all the terms inside the equation. So instead of positive 7x squared, we'll have negative 7x squared. Instead of positive 2x, negative 2x. And instead of positive 4, negative 4. And now all we've got to do is combine like terms. So I'll try and highlight a little bit. The 14x squared and the negative 7x squared go together. The 13x, the positive 13x and the negative 2x go together. Important to think of these with their signs. You don't want to think addition and subtraction so much as you do positive and negative. This way you can apply everything you know about adding integers together. So we'll take the positive 12 and the negative 4. And now we're just going to combine like terms. And let's start with the x squareds. 14x squared minus 7x squared, or 14 and negative 7 put together, is positive 7x squared. Positive 13 and negative 2, that's positive 11, and the x is just going to come along for the ride. Positive 12 and negative 4, that's negative 8. So here we have a nicely simplified polynomial expression. We will get into the definitions a little bit more. It's this term right here out front, the 7x squared, that is sort of moving us into the land of polynomials. But for now, just follow the rules of distribution and combining like terms, association and commutative properties, so we can simplify and combine like terms and take a long expression and combine it down into a simpler, smaller expression. I'll do 2 problems on the other side of the worksheet, and then you should be able to finish the whole thing on your own. So this is the top left problem on the other side of the page. The holes are now on the left side. So if there's anything about this problem that's throwing people, it's the parentheses around the 2 different expressions. And you could think, okay, yeah, it's like I have a positive 1 right here, and I want to distribute that positive 1 throughout the parentheses. Sure, that's true, but it isn't necessary because it won't change the value at all. So instead of distributing the positive 1, just drop the parentheses and combine like terms. 14x plus 5 plus 10x plus 5. 14 and 10 is 28, and 5 and 5 is 10. Don't forget the x on the 28. Just combine like terms. Nothing too difficult there. Alright, so this is the problem on the same side, same page, but now on the bottom right. If you can handle this problem, you're going to be just fine. And I'm here to walk you through it. So we've got a distribution that we want to start off with right here. We're going to distribute the 3x to the 5x and the negative 5. And then there's another distribution over here, but we're going to get to this one in just a minute. So let's just start. 3 times 5 is 15, and x times x, remember, x times x is the same as x squared. So 15x squared. Then 3 times negative 5 is negative 15, and that x will just come along for the ride. Now we've got the minus x and the plus 2 open parentheses. You could certainly distribute that too. I have no problem with that. But notice that you have some like terms inside the parenthesis already. You've got a 5x squared and a 3x squared. What's 5 plus 3? 8. So 5x squared plus 3x squared is 8x squared. So now let's go from left to right again, simplifying. Nothing's happened to the 15x squared, so bring that straight down. Negative 15x, just bring it straight down. Negative x, straight down. And now we've got 2 times 8x squared. That's the same as 16x squared. And now we'll just go about combining like terms. Negative 15x and negative x are going to go together. 15x squared and 16x squared are going to come together. And we'll end up with a total of 31x squared minus 16x. It's important to put the x squared term first. We usually write polynomials by decreasing degree. So there you have it. That's our simplified form of this polynomial expression. If you didn't really understand it yet, don't sweat it. We're going to start class with this on Tuesday. But I think this video should help you finish the page.